take it up.
Thank you very much, Kenan. Good morning, everybody. This is Mazdak Arabi. I am a professor of civil and environmental engineering at Colorado State University. And also, I serve as the director of the OneWire Solutions Institute, which is focused on developing water treatment technologies as well as software solutions for the water sector and related sectors such as land, energy, and agriculture. I'm joined with my colleague, Tyler Weibel, who is the Associate Director of the OneWire Solutions Institute. He has extensive experiences in software development and leads a number of our initiatives for creating software packages for the state of Colorado. Over the past decade, in collaboration with the Colorado Department of Public Health and Environment, the OWSI team has developed a portfolio of software solutions for water quality control in the state, with a primary focus on serving the CDPHE teams and groups, but also the clients and stakeholders that you all serve during your operations. So the purpose of this very brief webinar is to introduce you to some of the primary tools that we have developed to be able to engage the broader audience within CDPHE. And again, as I mentioned, some of the key target audiences that you may have in mind. We're not going to talk about all of the projects and data that we have produced in collaboration with CDPHE, but again, the intention of this webinar is to give you an idea of some of the primary tools that we have developed, and they are available for broader use by a variety of stakeholders. So before I get started with the portfolio of tools that we have here, it would be great if folks can mute themselves unless you have a question, so we can proceed with the webinar. Before I discuss this software portfolio and the specific tools that we have developed in, again, collaboration with various groups within CDPHE, I would like to mention that all of the tools that we have developed so far and we continue to develop are web applications, meaning that these tools do not need to be installed using any specific type of hardware or the server system. They are deployed as web apps and can be accessed by commonly used browsers. And all of these tools are powered by our software as a service platform. So we have a platform that enables creation of web applications called Catena Analytics with a software stack that is very robust and also is geographic information system enabled, is GIS enabled. So as I mentioned, there are a variety of data and modeling tools that are available, but primarily we wanted to highlight 9 of these tools, including the Rapid Watershed Assessment Program, or the RAP tool, the Watershed or Nonpoint Source Pollution Prioritization Dashboard, the Total Maximum Daily Load TMDL Dashboard, Colorado Water Assessment Tool and Reporter, Cold Water, Economic Feasibility Dashboard, Designated Planning Agency Resources, Water Quality Scenario Planning Dashboard, the SQUIMP or the Statewide Water Quality Management Plan, and Low Flow Analysis Dashboard. In the interest of time, we won't talk about all of these tools. We just will present some information about some of the tools that can hopefully provide you with some understanding of the nature of the purpose and the type of applications that these tools provide. Again, as I mentioned, these tools have been primarily developed in close collaboration and partnership with the Restoration and Protection Unit and the Nonpoint Source group, but there have been many other CDPHE technical staffs and experts and scientists that have worked with us over the course of the past decade to put these systems together. So with that, I'm going to pass this to my colleague, Tyler Weibel, to discuss some of these priority tools. And then at the end of the conversation, we'll talk about software support and our plans for delivering this software for seamless applications by CSU staff and, again, the clients that you serve and your customers.
Thank you, Mazdak. Again, my name is Tyler Weibel. I'm the Associate Director at OWSI for Software Innovation. I'm going to talk today about 4-ish of our highlighted dashboards that Mazdak presented. I want to clarify that I've got about 20 minutes to talk and about 20 minutes of questions. So feel free to think of questions that you have for the dashboards that we present, as well as the ones that we didn't, if you have questions and answers. And we'll talk about some of the bigger picture rollout of what next year looks like for a lot of those monthly webinars. The first dashboard that we want to present is the Watershed Rapid Assessment Program, or WRAP. This one's been around for about 8 years, close to a decade, in various iterations with CDPHE. And the goal of this one is to really streamline the analysis and collection of data available at different resources and agencies, right? So there's different groups in Colorado that publish data sets. There are different federal agencies that publish data sets. That's climate information, that's land use information, that's population, that's water qualities, sampling, etc. And those are disparate and time intensive to go fetch and retrieve for an area of analysis. The WRAP tool is really designed to streamline that access. With the goal of basically providing a one-stop shop for CDPHE staff so that they can say, this is my area of interest, this is the watershed I'm interested in, this is the community stakeholder group that I'm working with. These are the resources that they have access to across a suite of federal agencies, state agencies, and others, with the goal of basically taking the GIS side of it, right, the physiography, the hydrology, along with the time series side of it, so the water quality, flow data, and query all of that for their area of interest, and then export that in a number of different formats. The first one is just simply an overview, a rapid watershed overview report that says, this is your map, this is your data set, here's your pie chart, and things like that. The second one has been an expansion over the last couple of years with CDPHE to develop a streamlined and consistent template for EPA 9-element watershed-based management plans. I'm sure there's a few of you that know what that phrase means. There's a few that don't. That's okay. The idea is that this tool streamlines a lot of the data collection effort and then allows consulting companies, watershed collaboratives, and the like, DPAs, designated planning agencies, to basically leverage that template into an overall design for that they can submit to CDPHE and other groups in a very comprehensive fashion, with WRAP doing the heavy lifting of, here's your data set for Census Bureau, right? Go fetch all my population information, all the heavy lifting that it does behind the scenes. Inside of WRAP, there are a number of different data sets. You'll see a screenshot of that dashboard here. The left panel is really dedicated to the list of data sets, right? Specify your area of interest and pick what you want to go look at, or go generate that watershed-based plan. We've highlighted one of these. This is stream monitoring locations for you for the Cache la Poudre River in northern Colorado, because we're based out of CSU. It's the one we care about most. But you'll notice that it highlights on the map all the monitoring stations. It highlights a big table summarized below that of the different stations available. You'll notice that as you check on and off the data sets that you want to incorporate, it'll tell you, yes, this has water quality data, but not within the period of record that you've specified. You notice the start and end dates on the left panel. You've got a yes, no on flow data available within that same time period. And then you've got some hyperlinks for station name, because that one always overflows. It's a big long name that some people use, and as well as Zoom too, and some interactivity. But the point is, this style of map summary, table summary, and per data set is really what WRAP's designed for you. So you can checklist each one of these and go down one by one and review it for your area of interest. And this is anything as big as a Huck 8 or a county in Colorado, all the way down to my little watershed that's smaller than a Huck 12. If you have questions on what a Huck is, we'll get to that at the end. The Cache la Poudre is a Huck 8 for point of reference. Built into that are things like the standards database from you guys, the Water Quality Control Division. So you've got a summary of that. From that, we can also combine that with available observation data. So Cache la Poudre at Box Elder is a monitoring site at the Box Elder location on the Cache la Poudre. And we can combine flow data with water quality data and develop automated low duration curves, right? So it's a time-intensive process if you try to do that in Excel yourself. So this will generate all of that data set. You can download the images, you can download the raw data, you can download the shape files, right? You can download the rasters, you can download the image of the map. All of those pieces are exportable through WRAP. And like I said, the big one for WRAP in the last couple of years was that watershed based plan. That button's just on the top left and will automate all the steps. It'll check all the data sets. It'll generate all the images. It'll hand you back a zip file that has a dozen odd shape files in it, plus the templated report with your information inserted into it. But beyond that, we've done other dashboards. One of the ones that we want to highlight is the watershed prioritization dashboard, also known as the Nonpoint Source prioritization dashboard, which allows you to review existing watershed characteristics in for watersheds and areas of interest in Colorado. And this is really to prioritize things like, how do we allocate spending? How do we identify areas that need restoration versus need protection, right? We need to protect the things that are good. We need to fix the things that are bad. And how do you do that at a state level, at a county level, at a watershed level, so that you can actually get a meaningful sense of which watershed is the bad watershed? This leverages behind the scenes an MCDA, multi-criteria decision analysis, because there's 230 different indices for watershed health that are buried in this tool, or more. I can't remember off the top of my head if it's a little bit more than that. And to do that math one by one is extremely wasteful. So we leverage an MCDA to do that. This actually automates, those of you that are familiar with it, there's a framework called the EPA Preliminary Healthy Watershed Assessment Framework. It automates that healthy watershed assessment. So they have a default set of characteristics. We care about this part of land use. We care about this part of population density and a few other metrics. There's like 30, I think, in that list. And it'll automate that assessment and rank those watersheds for the protection needs or the restoration needs based on that method. There's also a huge expansion from those 30-ish EPA watershed indices out to the ones that are included in this dashboard, which allow CDPHE staff and general public users to customize what are you interested in, right? Do you want to go in? Identify the areas that are most impacted by abandoned mine land drainage? That can be answered here. Do you want to go identify critical watersheds in a region, right? These are the linchpins or the healthy ones that really have to protect the headwater streams, things like that. It also allows a framework to compare your watershed against other watersheds. So go ahead and advance, Mazdak. You start off by specifying your area of interest. This can be something as simple as, I care about all the watersheds in the South Platte. It'll go fetch all those. You'll notice that as you get into Wyoming and Nebraska, it cuts those off because this is a state of Colorado tool. You only keep the ones that are actually fractionally in the state of Colorado. Then you can specify your sub area that you care about, right? So one is just the area that I'm interested in. Then it's the zone on which that you want to prioritize, right? I care about Hub 10s within this watershed. And then it'll step you through automating the MCDA analysis. You can use any of the presets built into this tool. So the EPA Healthy Watershed Framework is a default that automatically weights things accordingly for the MCDA and turns on and off different indices based on that framework. We also have the protect one and the restore one. Those are pretty self-explanatory. And once you run that MCDA, you'll notice that the map updates with these are the poor health watersheds. These are the high health watersheds. And you can click on any one of those and review the information in the bottom panel of the base watershed data, the overview, water quality split out, impairments are split out, and then the MCDA inputs and outputs are split out as supplementary tables, just because there's, like I said, 200 different inputs into this. You can do at a glance, what's my natural land cover, right? That's an obvious one. So what's the natural land cover? You could sort these high to low. You can click on them on the map. You can click on them on the table, and they'll reverse engineer each other to go show you that piece of information, so that when you want to design your MCDA, you can say, okay, what matters to me? Do I care about how many miles of streams in this watershed are supporting their designated use, or are they impaired, right? That's one measure of an impairment. Or maybe you care about a very particular impairment, right? I only care about ammonia impairments. You can go through and tailor these analyses to prioritize the watersheds for your purpose. And this is just an example of how you can weight those different indices within their category and amongst categories, right? So you can weight impairments relative to other things like landscape condition and climate, or you can weight the different types of impairment within its own category. And you can weight them high or low, right? Is high good or is low good? And that varies based on population density. Is that a good thing or a bad thing? Is miles of impairment a good thing or a bad thing, right? Are you protecting or are you restoring? They're kind of an inverse, and you can override all of those different pieces to generate this information. You can also go through and review how your particular watershed sits relative to everything in the state and everything in your area of interest. So you'll notice there's a selector on this section for I want to look at Little Dry Creek and the South Platte River Basin. That's one of the HUC 10s. It'll show you that green dot across all of the different indices. This actually broke up in two different graphs because, like I said, 200's a lot. But you can see where your green dot lands for look at impairments of any kind, total miles. You're about halfway up in the selection. The blue bar represents all the watersheds you've grabbed. The gray bar represents everything in Colorado. So you can see the range of variability for the state as well as the area that you specified. And you can see, wow, there's a lot of ammonia impairment miles that are not in the South Platte River Basin. There's a bunch of the gray that's not in the blue, right? You can look at that at a glance and see how your watershed and area of interest stack at the state level or at the region level. And you can review all of that raw information. Another tool that we've worked on is the low flow analysis dashboard. This one's useful for a number of different reasons. This is useful in permitting. This is useful in standards. This is useful in aquatic life assessment and things like that for basically the streamlined quantification of low flow conditions. This is all based off the EPA DFlow tool for those of you familiar with that acronym and that algorithm. But what we've automated is a dashboard that will go through and pull all of the USGS National Water Infrastructure System, NWIS, monitoring sites as well as Division of Water Resources sites. So there's two sets of real-time monitoring gauges that exist across two different agencies and go automate that calculation. So you'll notice as that page loads real quick, this has graph map interface that you can go through and pick your point of interest across the state. You'll notice that, of course, the rivers are concentrated in the mountains and taper off in the plains, drier part of the region. But you can specify a number of different filters to get to that if you don't know where you're looking. If you're looking for a gauge ID, you can type in their name. If you know where it is on the map, you can select it that way. If you know site IDs versus names, you can or within a particular county, right? You can use any of those kind of clarifications. Once you do that, you can get this metadata summary on the right-hand side that basically says this is the gauge you picked, right? So this is the Casaputa River at Fort Collins. Again, we're sticking with our Fort Collins example. And then it'll go ahead and give you an overview of some of the information, right? What is the period of record for discharge? What's its flood data record? What's its 15-minute data flow discharge record? This one's not targeting water quality. This is a flow specific tool, so we don't summarize any of the water quality information. And then it allows you to go through and calculate the multiple different methods for low flow analysis. So extreme value design, biologically based flows, human health, and tailored with CDPHE, we've pre-built a Reg 31 flow summary. That's basically a series of biologically based design flows that are tailored to the month and year and frequencies that CDPHE likes to need. So there's a 7-day low flow, there's a 1-day low flow, there's a 30-day low flow, right? That's kind of the set that you need in order to look at Reg 31 flow conditions. And then, of course, when you run that analysis, you get the summary on the left that has all that content. Beyond that, we have a few dashboards that are in progress through the end of the year that are rolling out to their respective units. And then we're going to talk about what that rollout looks like to the stakeholders beyond CDPHE staff. One of those is the total maximum daily load, or TMDL dashboard. This one targets basically streamlining the process of compiling watershed characteristics for the assessors. That's pulling in standards, that's automating some of the analyses, that's pulling in watershed characteristics like what's in the watershed prioritization dashboard, and automating some of those index calculations so that they can have a point to start at that isn't, I need to spend the next 3 days going across 10 different data sources and getting that information. This is a point click, it does it all. So that they can actually leverage all of that contextual information and develop TMDLs for them. This has the basic, of course, the basic needs of look at the water quality on that stream segment, right? So for my stream segment or lake segment that's been flagged for TMDL, go give me the water quality upstream of that, right? So whatever the contributing water body is, watershed is to that particular point, those have been delineated. Based on that, we go pull the water quality monitoring stations and then pre-calculate low duration curves based on observed data, as well as we have a machine learning feature that's under review right now to quantify ambient water quality conditions, because you may not always have monitoring everywhere enough, and your stream standard, and then the difference between those is your pollutant reduction, right? So if ambient water quality is a particular number and the standard's lower than that, that's the reduction you need to aim for. That pre-calculates all of it. This was another dashboard that we've built with CDPHE is the Ecom feasibility dashboard. This one is in collaboration with the standards unit as opposed to the TMDL group. It targets a slightly different audience. It targets meeting some of their needs for some statewide equity kind of questions, right? What is the ability to pay for the number of ratepayers that a municipality has for the treatment plants and things like that? So that's the drinking water side, that's the wastewater side, that's all the pieces. And then just contextualizing a lot of the information around permits, that's their IDs, that's their site-specific variances, as well as providing a public-facing portal for the stakeholders to go in and manage their information relative to the copy that the state has so they can collaborate, fix things, right? As they get a new census or survey that's done by a consulting company pulled in, they can get that pulled into the dashboard using their version of that portal. The idea is really so that you can look into the economic feasibility of technology increases at their facilities, right? So as different processes come online or need to come online for drinking water or wastewater, what's the ability of that community to pay for it? As water quality standards change, what's the ability of that community to pay for the changes necessary to their facilities to meet that regulatory structure? It also has a number of different contextual pieces for assessing population trends and demographics and correlations and water quality and water flow, all of the pieces in there.
Thank you, Tyler. I really appreciate that. As I mentioned, this is just a summary of some of the tools that have been deployed using our Catena Analytics platform for a variety of CDPHE and the broader watershed stakeholders in Colorado. One of the key things that we are working with CDPHE right now is to improve our software and technical support for the use of these tools across different departments and stakeholder groups. And what we're going to do over the course of next year is to have a complete set of user guides and instructional videos for every tool to be able to walk through all of the functions and applications with good examples that the user can follow to use the tool for their own specific watershed or conduct regional assessments. We are going to host regular and frequent dissemination webinars. This will be available for tool-specific presentations and disseminations, as well as this type of information about the broader suite of tools that we are putting together with CDPHE and our partners. Also, we are going to offer user technical assistance and training sessions. We will have, right now, our plan is to have quarterly technical assistance and training sessions that are offered both in person and via video conferencing, but also we'll make these sessions available upon request by users. So we can, again, make these tools available to the broader community. The next year effort is highly focused on software support. As Tyler mentioned, the suite of the 9 tools that we talked about and the data that are embedded in all of them will be deployed. Many of them are already deployed in a complete fashion. For the remaining parts, by the end of the year, we'll have a complete deployment, and therefore, again, user support and tech support becomes increasingly important for year 2025. To be able to disseminate information about the tools that are available, also a calendar of events, whether they are informational webinars or dissemination webinars or hands-on training workshops. We have a webpage that summarizes the catalog of the software tools that we have developed with CDPHE. You can use this URL shown in this slide to access these tools. As I mentioned, many of these tools are already deployed in a complete fashion, and some of them we are finalizing by the end of this year to be able to, again, use it for a variety of applications. Every software or tool that you see here will have its own landing page with access to how to launch the tool, videos, and user guides, as well as a calendar of events that we are putting together to show when the webinars are going to be offered for that specific tools and how people can get technical support or something that recently we call office hours for each of these software packages. We really appreciate this collaboration between the OneWire Solution Institute at CSU and CDPHE. We think that these tools can be widely used with our technical support to address many wire quality control issues. And we are really interested as a part of this webinar to learn from your perspectives and also any questions that you may have, avenues and mechanisms that we can use to reach out and make our technical support available for your use cases and any other related topics that you would like to discuss. So with that, I'm going to stop here, stop sharing our screen, and then open this for conversation and discussions.
I'll make one small comment before that. Just to recap, as far as the rollout for what next year looks like, you're going to look at something like monthly-ish webinars for tools. You're going to look at quarterly workshops. Those workshops are going to be the hybrid in-person plus remote. We have a presence on all of CSU's campuses. So we've got a presence at Spur, we've got a presence in Fort Collins. So we'll be traveling down to Denver for you. You don't have to come up to Fort Collins to us. So that those sort of logistics are all things that we're keeping an eye on as it goes into next year.
Thank you, Tyler. I think that was a very important clarification that with the CSU's Spur campus down in Denver and the presence of the OneWire Solutions Institute at the Hydro building, we have a lot of good capacity opportunities for in-person training in Denver area. So hopefully that makes it more accessible for the broader group in CDPHE or other stakeholders and clients and customers that you work with. So with that, Kenan, I would like to pass it to you to see if you have any comments, and then we can open it up for conversations and discussions by the broader group.
Oh, thanks for putting this presentation together, guys. And hopefully next year we will have those more specific presentations for each tools. And that will, I think, encourage the use of those tools within at least CDPHE and or of course for stakeholders too. With that said, any questions to Tyler, Mazdak, myself, or what tool you guys would think would be useful, whatever you saw or whatever the name you guys seen amongst 9, that will be kind of helpful if we can get either right now or send me an email or Mazdak or Tyler so that we can prioritize tools next year going forward. Any comments?
That can also be as simple as I saw the name, what's the tool do?
Right. If not, I go to lunch and be merry.
I have a quick question. I have a login for CoWater. Do all these other tools require logins, and do they translate between the tools, or do you need a separate login for each one?
Great question. I'll field that one. Most of these tools are public facing. So things like WRAP, watershed prioritization, low flow analysis, all of those are public facing and don't require a login for those features. CoWater, TMDL, Econ feasibility are probably the one-offs that do. TMDL and Econ feasibility leverage the same infrastructure for the login. CoWater is the odd duck that its login will always be separate from the other ones because of lots of complexity for the way the data is accessed behind that one. CoWater's got a couple thousand data entries that get generated every year, and it's just a different infrastructure to make that happen for various reasons. But CoWater's a one-off. All the rest of them will leverage no login or the same login.
Yeah, the CoWater that Tyler is talking about is basically developing 303D assessments for SCIPS group, and per SCIPS group's request or want, it is login required. And if a group wants the tool be not accessible, then there is login required. Otherwise, they should be public.
This is a great question. As you register as a user using Catena Analytics computing platform, which is called eRAMS, so you will get an email from eRAMS.com. That login credential will allow you to access all of the tools if they require login. As Tyler mentioned, some of the tools are public facing, like the RAP tool, the Watershed Rapid Assessment tool, and does not necessarily need a login, although we are going to create a login version of all of the tools because that allows you to save your previous reports in the dashboard, and therefore you don't need to redo the analysis if you return to an area of interest for the same analysis that you have conducted previously.
That's a good point too, Mazdak. Yes, repeatability question. Any others?
As folks are thinking about potentially questions or comments, again, we would like to encourage you to think about how best we can deploy these tools to serve you best. That's ultimately the purpose of all of these activities, are to make CDPHE folks save time and effort on some of the analysis, or have a consistent basis for the analysis, particularly as it comes to access to data, a consistent and comprehensive access to the data, whether it's state, local, or federal data from federal governmental agencies. So in this regard, just let us know what type of deployments of these tools would serve you best. We are open to all sort of suggestions, including mobile deployment in some cases, not for all possible tools, but for some tools you may benefit from a mobile deployment that could, at a given site, help you with summarizing some information for those purposes. Please send us your comments in the chat for this training webinar, or for this dissemination webinar, or just email Kenan, Tyler, me, or anybody at the OneWare Solution Institute. We would be delighted to learn about your comments.
One quick one from the chat. It sounds like a few of you are perusing our website. We have a page specific for the CDPHE. We also have a page specific to all of our tools. OWSI has other projects that weren't funded by CDPHE, but they're sometimes relationally important. So we've developed the CDPHE landing page for, this is the list you paid for, plus some relevant ones. And then the other list is everything, right? And the everything is only the public facing ones, right? So the TMDL tool, the co-water tool, those don't have entries on the everything page because they're not public facing, they're CDPHE facing. So that's one quick clarification.
Yeah, that's a good question, Dave. Thanks.
I might just add to the CDPHE landing page is still a work in progress. So we're getting that finalized with content from a wide variety of CDPHE participants. So hopefully by the end of the year, that'll be all updated.
Right.
Including the calendar of events for webinars and training workshops. So when you go to each page, you will see hopefully a calendar of events that says, our next webinar is scheduled for this date, or we have a training session on a given date. And you can then request also specific training events that fits your schedule as well. You just have to schedule it as needed. Well, thank you, everybody. We don't want to take folks for too long. We appreciate your participation in this webinar. And thank you particularly to our colleagues at CDPHE that have been essentially serving as product owners for these software packages and tools. Without their insight and help and commitment over, again, as I mentioned, for a decade, we would not be anywhere close to be able to roll out our software packages by the end of this year and then support them in the following year. So thank you, everybody. We really appreciate it.
And one last highlight. This
Oh,
meeting
boy.
was recorded and we'll be disseminating that to you guys. So if you have colleagues that couldn't make it today or had other commitments, that's why we recorded it, so that everybody can get the same point of resource or recall something that you missed.
And last, I think there is a good question from Kelsey that when do you expect to release the schedule of training and webinars? We are hoping that by the end of this year, the CDPHE software portfolio webpage is complete. So the description of the tools and the potential applications of the tools are there, with a calendar of events that has webinar and training sessions embedded in each page for every tool.
Nice.
Thank you, everybody. Have a great rest of
Thank
your
you
day,
so much,
and
guys.
see you
Have a
soon.
great
Bye-bye.
day. Bye.